Hello, this is Brother Cromer from the Math Department at BYU, Idaho, and I'll be covering Lesson 23, dealing with simple linear regression. And so here's the outline for these videos. First, I'll talk about the difference between a response and an explanatory variable. Follow it up with a linear regression equation. You'll need to know the response and the explanatory variable in order for you to do a linear regression equation. Then we'll be dealing with prediction. We'll need the regression equation to do some predictions, and then finally I'll briefly talk about fitting a line in a scatter plot. So first of all, let me go back to this. First of all, let us talk about what an explanatory variable and response variable is. Explanatory variable is used to predict a response variable, and I'll go through a couple of examples of those in a moment. Now I just want to mention here that explanatory variable could also be called an independent variable or an X variable. Now the response variable can also be called a dependent variable as well as a Y variable. So let's go through a couple of examples between an explanatory variable and a response variable. And I'll go through these two examples throughout the video. So the first example is predicting body length of a crocodile using head length. Okay, so our response variable is what we're using, or what we are predicting, and our explanatory variable is what we are using to predict. And so since we're using head length to predict body length, head length is our explanatory variable, and body length would be our response variable. Now the second example, and both of these examples on the online textbook, does the number of powerboat registrations affect the number of manatee killed? So we're trying to predict the number of manatee killed based off of number of powerboat registrations. So that means the explanatory variable is the number of powerboat registrations, and the number of manatee killed would be the response variable. Okay, so we need to know the difference between the two because the next item is dealing with the linear regression equation. So the linear regression equation is basically going here is y hat is equal to b naught plus b1 times x, where b naught is the y-intercept and b1 is the slope. Now you've seen this something similar before, where y equals mx plus b. That's the y-intercept. That's the slope-intercept form of an equation. Now, we'll be dealing with this with a statistical bent, where we're going to take some data and we're going to try to fit a line based off of that data. And so now we need to interpret two things, the y-intercept and the slope. The y-intercept, that's where the regression line intersects with the line where x is equal to 0. Sometimes it's appropriate to interpret and sometimes it's not. Now the slope, on the other hand, is as x, or our explanatory variable, increases by 1, then our y, our response variable, increases or decreases on average based on the estimated value of the slope. So if the slope is positive, then y would increase, and if our slope is negative, then our slope would decrease as our explanatory variable increases by 1. Okay, so let's talk about the first example with the crocodiles. Now, if you did this, you can go to the online textbook and you can get the link to the data and open this up. Now, if you did this in SPSS or Excel, what you would do is you would get the linear regression equation where y hat is equal to negative 18.274 plus 7.660 times x. Now, how did I get those numbers? Well, I got it from this table here. This is an SPSS table, and Excel has a similar table where I got the y-intercept here with this number, and then the slope, I got it from this number here. So it's all under the column under capital B. So these represent our two b's, b naught and b1. Okay. Now how we interpret the y-intercept, that's where head length is equal to 0. So if we plug in x is equal to 0, body length would then be equal to this number here, negative 18.274. So that would be inappropriate to interpret in this case, since you cannot get a negative body length. So the slope is that, however, we can interpret basically by saying as head length increases by 1 centimeter, body length increases on average by 7.660 centimeters. Now, if this slope were negative, then that would mean that means that as head length goes up by 1, body length would decrease by 7.660, so that would be impractical in this situation. But that's just to describe what happens to the slope, whether it's negative or positive. Now the second example, I want you to go through. If you like to, you can stop the video and go through this. The link to the manatee data is in the online textbook. Okay, so how do you get the linear regression equation? This is the linear regression equation, where y hat is equal to negative 42.542 plus 0.129 times x. Now how I got those numbers is that I got it from this table right here. Okay, so negative 42.542 is my y-intercept and 0.129 is my slope. So how do we interpret that? Well, if the number of powerboats is equal to 0, the number of manatee killed would be negative 42.542. But this would not be appropriate or be inappropriate to interpret, since you cannot get a negative number for manatee killed. Now for our slope, we can interpret that, whereas the number of powerboats registered increases by 1 or 1,000, since the numbers are in 1,000. The number of manatee killed on average would increase by 0.129. Okay. So now, with that, we can do some predictions. Okay, we can predict a y variable based off of an x variable, or we can predict a response variable based off an explanatory variable. And what do I mean by that? Well, let's go through a couple of examples. For instance, predicting the body length of a crocodile when the head length is 60 centimeters. So what we can do is that we can take this regression equation that we created a few slides ago, and we can plug in 60 centimeters for x and then solve for y. Okay, so we can get a predicted body length. Okay, so if you can use this, or you can get a prediction of y using SPSS or Excel, and if you do that, you would get a number of 441.332. Now you can also use a calculator to take 7.660 times 60 and then subtract 18.274 to get this number. In this situation, the numbers are fairly close. Now if you look at the bottom right, here's a scatter plot, and then I fitted a line which I will cover briefly at the end of the video, where if you have 60, if you go up to this point of the regression equation, that would be about 441. Okay. So now the last example is predicting manatee killed in a year, given that there are 800,000 powerboats registered. So I would take the regression equation that I created a few slides ago, and so what I'd put in instead, it wouldn't be 800,000 because the numbers were in thousands, so I would put in 800 instead. So I would take 800 times 0.129, subtract 42.542 if you were to do this on a calculator, and you would get this number right here. If you did it using Excel or SPSS, you would get this number. So I rounded up to about 61, so there'd be about 61 manatee killed if there are 800,000 powerboats registered. Okay, and so if you go down below here where there's 800, you can see that it's about 61 or so predicted number of manatee killed within a given year. Okay, so the last thing I want to talk about is fitting line in a scatter plot. And there's tutorials that you can follow with this, or there will be a video created for how to do this in SPSS. Now here are the two fitted lines on the two scatter plots, one for crocodiles, one for manatees versus powerboats. Okay, so how many manatee were killed based on the number of powerboats registered in thousands. Basically, I wanted to show you here is that here's the regression equation, and here is the fitted line in the scatter plot. So if this were to go all the way to 0 if x is equal to 0, this line would hit where it's negative 18.274. But as we go up by 1, the body length in centimeters would increase by 7.660. And then also with this scatter plot here, if we were to take this all the way to 0 here, where x is equal to 0, it would be somewhere over here, then y would be equal to negative 42.542. But as we increase, if we increase the number of powerboats by 1,000, then the number of manatee killed would go up by 0.129. Okay, and that's what I wanted to mention here on these. But if you want more detail, there'll be an SPSS video or a Excel tutorial in terms of how to fit a regression line on a scatter plot. And that concludes the lesson 23 video dealing with simple linear regression.